Hello guys, so welcome back once more to Classic Knowledge Quest. I am Kelvin Ikenna Ikechukwu. And so join me, let's keep playing with physics. Of course, you must have come to a reality that physics is not as difficult as it seems or it's being positioned to look like. Physics is a very interesting subject. So let's continue. In our previous class, we talked about motion. We defined what motion is and its importance, and we looked at the 3 dimensions of motion, the 1 dimension, 2 and 3 dimensions, and gave some examples, and we did a little introduction to the types of motion. So in this class today, we'll be looking into the type of motion, although we will not be going deep into details, but I'll be explaining the types of motions and giving their examples, and then also look at parameters used to describe motion. So I want you to stay put and let's begin. So the types of motion. We have majorly 4 types of motion. And the first, but not the least, is the random motion. From the word random, it means something occurring without a pattern. Something occurring without a pattern. It occurs randomly, something moving in a zigzag way. So if you should notice something continually moving in a zigzag way, going up, going back, going east, going west, coming, just jumping up and down, such type of motion is termed as random motion. For instance, if you love football, when the players in the field, this one will run to this place, this one will run to this other place, this one will come back, this one will run. Such type of motion is said to be what? A random motion. Another type of random motion is like the Brownian motion. Brownian motion. That is the motion of the particles or gases. When you see a gas moving, there is a lot of particles. Majorly some gases and all these things normally carry out such things like smoke, a dust, and all of them undergo what? A random motion. Now, the second type of motion is the translational. Translational, or also called linear motion. Now, translational simply means movement in a straight line. And the same thing occurs with linear. Now, a body or an object is said to undergo a translational motion if it is rigidly moving in a straight line without rotating, without somersaulting, without rotating. Such object is said to undergo or carry out what? A linear motion. For instance, I am walking. I am walking. I am walking. I am carrying out what? A translational or linear motion from point A to point B. But when I start moving and my head will go down and I start using my head to walk, and then I start using my chest, I start using my back, such type of motion again is not called a translational motion. It simply means a rigid system of movement with one specific part of the body. That is what is a translational motion. So example is you walking down a vehicle traveling from, should I say, from Abuja to London, a plane flying from Jamaica to New York. So far they are moving with just one system. It is a translational motion. Okay, so the third is, what is the third type of motion? The third type of motion we have here is the rotational motion. From the word rotate, you should know it is something spinning from an axis point. When an object keeps spinning from an axis point to returning to that same place and not leaving that axis point, such type of object is being said to undergo a rotational motion. Examples are the blades of the electric fan. They keep rotating, The earth itself rotating around its axis in every 24 hours. All these are examples of rotational motion. A sports person who is performing gymnastics, maybe you're somersaulting and all this, you're also undergoing what? A rotational motion. And the fourth type of motion is the oscillatory, also called vibrational motion. Some textbooks also call it periodic motion. So when you hear the word oscillatory, vibrational, periodic motion, it is simply the same thing. Now, this is a type of motion that is classified as a to and fro. A to and fro. To and fro. It is a motion in which an object moves forward, come back to a starting position, goes behind it again, return to a starting position, and move back. So there's a continuous swinging of an object. When an object takes such pattern, it is said to undergo an oscillatory motion. Example of it is a pendulum. Example of it is your swing. When you are in the swing and you're swinging through and flow. Another example is your bass guitar. When the string is being displaced, you see like a form of a vibration. So such types of motion is called an oscillatory or a vibratory or a periodic motion. Then another aspect of motion we will look at is the concept of relativity. That is relative motion. Relative motion. Some people classify it as a type of motion, but it is a concept on its own. Relative motion now is a concept of motion that makes us to understand or observe that every object is moving in a relation to another. What it simply entails is that there is no absolute motion, that anything moving is moving in a relative or a relationship with another object. I will explain this further now with a simple illustration. If I'm in a car or a luxury and that luxury is moving, the person sitting down next to me, normally I will feel like that person is not moving because we are in the same object, we are at the same relative motion. We are moving at the same speed. So that person seems to me that like he's not moving. But when I look outside and I see someone standing by or a tree, you will see that person, boom, you'll be seeing it like if those trees are running. The reason being that you are now in those objects and you are not in the same speed. So therefore, you now see those things moving. Also, it's the same thing as someone standing in a spot outside. That person looking at your vehicle will see that vehicle as the vehicle is moving. But you inside the train or even inside the plane will not notice. You will feel like you are not moving. So this is just simply a nice concept that states or makes us understand that every object is being calculated or seen as being in a relative motion with another object. Without such object is not being considered or seen to be moving. There must be a relativity of it with something else. So I think we have done much here. So in our next class, we'll be talking about what the parameters essential for the description of motion. So please stay glued. Invite your friends, invite your relatives, invite students to come and learn physics without any form of cost. See you in the next video. Bye for now.